Okay, let's say that we've got a random variable x which follows a binomial distribution with 15 trials and the probability of success on each trial is 0.4. So x is going to be the total number of successes that we have out of those 15 trials. So let's have a look at how to work out this probability. The probability that x is greater than or equal to 11 but less than or equal to 14. Let's draw a little diagram just to help us think about these. So I'm just going to put the integer values and I'm going to just put ... and then I'm going up to round about 11. So I'm going to include 10, 11, 12, 13, 14, 15. And remember, we can't have more than 15 because x is the number of successes in 15 trials. So the maximum value of x is 15. Well, we want greater than or equal to 11. So we want to include 11, but less than or equal to 14. So we want those probabilities there. So this is really easy to do if you've got one of the newer coloured calculators, which has been updated. You can go on Statistics, Distribution, Binomial, Cumulative. Just put the lower as 11, the upper as 14, the number of trials is 15, and the probability is 0.4. And that's going to add up the probability of x being 11, x being 12, x being 13, and x being 14. It includes the lower and the upper values. And you could get that probability. It's a little bit harder if you've got one of the older calculators because the older calculators only give you a probability of x being less than or equal to something. So what we're going to do is we're always going to use the same method to work this out. We're going to work out what's the probability of being less than or equal to our top value here, so 14. And that's going to give us the probability of being in this red region here. So that's the probability of x being less than or equal to 14. Now the problem with that is we've included x being 0 up to 10. So what we need to do is we need to subtract the probability of being in this region here from 0 up to 10. So that's the probability of x being less than or equal to 10. And if I do that subtraction, I'm going to end up with just this probability of 11 to 14. So let's work out these probabilities. So we go to a calculator, Statistics, Distribution, Binomial, Cumulative. Number of trials is 15. And the probability of success on each trial is 0.4. Now we want the probability of x being less than or equal to 14. That's our red probability. And that's 0.999989. So really big probability. And I'd recommend using the unrounded value when you use this method on the old calculators. Next, we need to subtract the probability of being in this region, which is less than or equal to 10. So we're just going to change that to 10. X is 10. And that's going to give us all the probability from 0 up to 10. And if we subtract those two probabilities, we get the probability of being between 11 and 14 inclusive, which is 0.00935 to 3 sig fig. Let's take a look at another one. Let's say we wanted the probability of x being greater than 4, but less than 10. So again, I would always recommend drawing out a bit of a diagram just to help us think about these numbers. You don't need to write them all down as long as you've got the numbers that are included here and the one up, the one above and the one below each of the bounds. So I've included 3 and 5, and I'm going to go 9, 10, 11 up to 15. Okay, so these are our possible x values. We want x being greater than 4, so more than 4 successes, so we need to be 5 or higher. So we want to include 5, and we have to be less than 10, so we want 9 or fewer successes. So basically we want, this is the same as saying we want the probability of x being greater than or equal to 5 and less than or equal to 9. So what we're going to do is we're going to use the same method before. We're going to work out this red bracket here. So what's the probability of x being less than or equal to 9? And we need to subtract the probability from 0 up to 4. So subtract the probability of x being less than or equal to 4. So to get that probability of x being less than or equal to 9, we just change x to 9 in our cumulative binomial. And again, I'm going to use the unrounded value to get the most accurate answer possible. And then I need to work out this blue probability of x being less than or equal to 4. So I'm just going to change x to 4. And if we work that out, we get 0.749 to 3 sig fig. So the places where people make mistakes with this are they don't draw out this diagram and they get their bounds wrong for the red probability and the blue probability. So I'd recommend you always draw a diagram like this.